I'm recording your class. This is 14 January 2026, and we are starting crash course. And the first topic is refraction of light. And in this course, we are starting this topic with this example. Consider this is a ray of light. This ray is called incident ray, and this incident ray is striking with the boundary of water, and when it strikes on the boundary of the water, then obviously it is entering into the water, and the density of water is greater as compared to air. So when light enters into water, then it slows down, and the speed of light in water is 2 exponent 8 meter per second. So when light enters into water, it cannot continue a straight path. It cannot continue the same path. It will bend into the water. It will bend into the water. And if I draw a normal means a line of 90-degree with the boundary, then this line is called normal. So the original path of this incident ray is like this, but when the light enters into water, where it slows down, then it cannot continue the same path and it bends towards the normal. And this phenomenon is called refraction of light. So if you write two lines for this refraction of light, then we will discuss its formula and then we will start solving past paper questions. Okay. And in crash course, and then obviously the main focus is to practice past paper questions. Okay. So we are starting with refraction of light and note down this statement: when light changes medium. Changes medium means in this example, the light is traveling from air into water, but it is also possible the light is traveling from water into air. So when light changes medium, its speed changes, its wavelength changes, and direction changes. Speed changes, wavelength changes, and direction change. No change in frequency. In refraction of light, there is no change of frequency. So the direction changing, wavelength changing, speed changing, and this phenomenon is called refraction of light. And the angle between incident ray and the normal, this is called angle of incidence. And the angle between normal and refracted ray. The ray inside the water, it is called refracted ray. The ray in the air, it is called incident ray. The angle inside the water, it is angle R. And you must memorize it. Sir, when light enters from air into glass, then light ray bends towards normal. And when it bends towards normal, then we have a formula, and the formula is sine, in trigonometry, sine cos tan. So it is sine angle I divided by sine angle R. And I am asking Amna. Amna, can you tell me what is the name of this physical quantity? It is very simple. Sine I upon sine R. What is the name of this physical quantity, Amna? Amna, can you tell me what is the name of this N? Amna, Amna microphone is not working. Acha beta, Faria, can you tell me what is the name of this physical quantity which is denoted by N? Faria? Okay. This physical quantity is known as refractive index. This physical quantity is known as refractive index. Okay. So note down this formula first. Yes, this is IGCSE. IGCSE, as well as I should ask you, are you a student of Excel physics or are you a student of Cambridge board? Okay, Shukar Alhamdulillah, because this is class of Cambridge as well as IGCSE, and the paper code of your course is 0625. Faria beta? ओके ओके। अगर आप एडेक्सेल की होती तो आपको मैं एक दूसरी क्लास में शिफ्ट करता, ठीक है ना? तो आई डू नॉट मिक्स दीज स्टूडेंट्स, आई टीच देम सेपरेटली. सो राइट नाउ यू आर इन क्लास ऑफ Cambridge board, paper code is 0625. So this is very simple formula which I have taught you, and this formula is called diffractive index. This is called diffractive index, and I for angle of incidence, R for angle of refraction, and in this example, water is used as a denser medium. But as you could not tell me the name of refractive index, it means I should explain you further about refraction of light. Consider this is Faria, a glass block. This is a rectangular glass block, and I will send you some videos from YouTube as well, in which you can see how do we experiment in the lab. This is a glass slab, and in this glass slab, if I use a torch light which is striking on the boundary of the glass slab, then this is the original path, but the light will not follow the original path. Sir, it will bend. It will bend. When light enters into a glass block, then this is called angle of incidence. This is called angle of refraction, and light is not continue the straight line, but it is bending. And the bending of light, it is called refraction of light. Abata Faria, I am repeating and you have to explain what I am saying. The topic is refraction of light. And in refraction, Beta Faria, this light is called incident ray. This light is called refracted ray. When light enters into water, when light enters into glass, then its wavelength decrease, its speed decrease, as well as its direction change. And this is called refraction of light. Habita Faria, can you say something about refraction of light? Angle, this angle is, yes, this is called angle of incidence. And I think I should redraw here. This is the boundary of glass block. This is the boundary of glass block. This is the incident ray. This is the incident ray. And this is the normal. And this angle is called angle of incidence. This is the original path, but the light will not follow the original path. Light is bending. Light is bending towards the normal. And this angle is called angle of refraction. So this ray is incident ray, and this ray is called refracted ray. This angle is called angle of incidence. This angle is called angle of refraction. And you should memorize this formula: sine I divided by sine R, and their ratio is called refractive index. जी बेटा, फारिया, can you say something? जी. This formula is used to calculate refractive index of the medium. Actually, refractive index is a property of medium which shows how how much refraction of light will occur in that medium. If the refractive index of water is less and the refractive index of glass is greater, it means there will be greater bending of light in glass and there will be less bending in water. So this formula is used to calculate refractive index of medium. And medium for this example is glass. Ji beta Faria, have you noted? Okay. If you have understood, then say something about what is the refraction of light. I am repeating and then you should explain. I am repeating, then you should explain. Sir, when a ray of light in air enters into glass, then it bends towards the normal. When light in air enters into glass, it bends towards normal. This is called refraction of light. Ji, Faria, what is refraction? Sorry, what is refraction of light, beta? Faria? Yes. एंड फारिया बेटा आई थिंक यू आर फारिया अभी हम फारिया से बात कर रहे थे अच्छा आमना बेटा कैन यू से समथिंग आमना योर माइक्रोफोन इज वर्किंग और नॉट इन वर्किंग ओके 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 एंड नाउ आई एम स्टार्टिंग क्वेश्चंस बेटा नेविया अस्सलाम वालेकुम नेविया अस्सलाम वालेकुम बेटा राफे अच्छा बेटा राफे एंड अम्मार दे हैव completed already their course Nevia and Faria and Amna they have just joined our classes and I think uh, their pace or we should not discuss their pace. Okay, the question is, beta, this is the question on your screen, beta, Faria. This is a glass block, and on this glass block, this is normal, dotted line is the normal, and this ray is the incident ray. This ray is the incident ray. Beta, Navia, can you tell me what is angle I, what is angle R? Angle I is 29 and angle R is 33. But your answer is wrong because angle is measured with normal. Yes, the angle is measured with normal. Okay, this angle is with boundary. This 29-degree angle with boundary. So this is not angle I. Angle I is the angle subtended by ray with normal. And with normal, this angle is 61 degree. So this is not 29. And now we have to calculate refractive index. So we are calculating refractive index. The formula to calculate refractive index is sine I divided by sine R. Okay, this is the formula to calculate sine I upon sine R. And now I am, okay, I'm using calculator. This is sine 61 divided by sine 33. So the answer is 1.6. The answer is 1.6. And there is no unit of refractive index. There is no unit of refractive index. Okay. Acha beta, Amna, you do not note down this calculation. And when my class be completed, I will share you this PDF on your number as well as I am recording this class. And I think you should watch the recording of my class as well because I should run fast because we have hardly 3 to 4 months. And if I teach you at slow pace, then obviously I cannot complete your course. Okay, but so I will move fast, but you should watch video and focus on understanding. Do not write. Okay, I will share you this work just after my class. And now this question is completed, and now this is another question. Sir, in this question, this is a red light, and this red light right now it is in air, and this light is entering into glass. I taught you when light changes medium, its path change. But in this question, you can see the light ray is going straight. There is no change in path. There is no change in path. And the question is, sir, why the light does not change direction as it enters the glass block at P? But Nevia, can you answer me why the light is not changing its direction? Nevia, I have taught you earlier. Nevia, beta, do you know? Uh-huh. No, no, no. The reason is, sir, whenever light ray incident on a boundary at 90 degree, whenever a light ray incident at 90 degree, then there is no change in direction. There is no change in direction. So the answer is as light ray enters perpendicularly, perpendicularly to the boundary. When light incident at 90 degree, when light enters perpendicular to the boundary, it does not change direction. It does not change direction if the light incident at 90 degree. Okay, beta? Acha ji, now I'm teaching you a new thing, and the new thing is, sir, light here, the light is in glass. The light is in glass. Okay, and this ray is incident ray, and this ray is making 30-degree angle with normal. This ray is making 30-degree angle with normal. Then angle I is 30 degree. Angle I is 30 degree. And in this question, you have to calculate angle of refraction. You have to calculate angle of refraction. We have to calculate, okay? But the light is traveling from glass into air. But Navia, I taught you when the light traveling from glass to air, then what is formula of refractive index? Navia, can you tell me the formula of refractive index if the light is traveling from glass into air? Yes. Beta Amna, beta Faria, note down. The formula is reciprocal. It is not sine I upon sine R. It becomes sine R divided by sine I. When light travels from glass into air, then the formula is not sine I upon sine R. The formula changed. It is sine R divided by sine I. And in this question, sir, we are given refractive index. Sir, refractive index is 1.5. So I am using this formula. I am using this formula. Sir, formula is refractive index 1.5. Refractive index 1.5 is equal to sine R divided by sine I. And the formula, the sine I is given. It is 30 degree. Angle I is given. It is 30 degree. Okay, and we have to calculate angle R. We have to calculate angle R. Sir, how do we calculate? I am showing you calculation. So this sine 30, but Amna, are you asking something? This is 1.5 with sine 30 is equal to sine r, is equal to sine r. Okay. And now I am using calculator. I am using calculator to calculate angle R. I am using calculator. In calculator, I am writing 1.5 into sine 30. Then the result is 0.75. The result is 0.75. Sir, you have to calculate angle R. And if you have to calculate angle R, then Amna, can you tell me if you are given sine R, then how do you calculate angle R? Amna? Amna? Yes. This sine becomes sine inverse. This becomes sine inverse. So I am calculating angle R. And how do I write sine inverse? Then I will press shift or second key and then sine. Then on the screen you can see it is sine inverse. Sine inverse of 0.75. So the answer is 48.6 degree. So the angle is 48.6 degree. Or you can round off to 49 degree because you have to draw the path of light as the light emerges from Q. Okay, so here you have to draw the path. You have to draw the path. Okay, so you will measure angle. You will measure angle, and the angle with normal will be 60 degree. Sorry, 48 point or 49 degree. Because on protector you cannot read 48.6. It is very difficult to read 49 degree. So you will draw emergent ray at 49 degree. So, but Amna, in this question, you have learned when the light is traveling from glass into air, from glass into air, then the formula is sine angle R divided by sine angle I. As well as you can see in air, the light is bending away from the normal. The light is bending away from the normal. This is normal line, and you can see the light is bending away from the normal. Okay, so you have studied two formulas. Formula number one, sine I upon sine R, and new formula I have taught you, Amna. It is sine R divided by sine I, and this formula is used when light is traveling from denser medium into air. From denser medium into air. The first formula, it was air into denser medium. The first formula was air into denser medium, and the second formula is glass into air. ठीक है? अच्छा जी, now we are solving next question. This is the next question. And in this next question, beta Amna, in this question, the examiner is checking, can you read protector? Do you know how do we read protector? This is the boundary. This is the protector. This is the 90-degree angle line that is called normal. This is the incident ray. This is the incident ray. So, beta, Amna, can you read this angle? Can you read this angle, Amna? Amna, are you trying? अच्छा, इन लोगों का इंटरनेट बहुत खराब चल रहा है शायद. अच्छा बेटा, नेविया, कैन यू रीड? हाँ, okay, it is 35. Amna has rejoined. Amna beta, can you read the angle? This is 90-degree angle. Yes, this is 90-degree angle. Okay. And 90, this is 80, this is 70, this is 60, and this is 55 angle. Okay, this is 55-degree angle. But we will read from 90-degree angle. 90 is the starting point, 55 is the ending point. So 90 minus 55, 90 minus 55, so the angle is 35 degree. So the angle is 35 degree. So this is angle of incidence. This is angle of incidence. And this light right now is in glass. Okay. And then we are given refractive index. We are given refractive index. But Navia, light is traveling from glass into air. What is the formula to calculate refractive index? Navia? Nine. It will be sine R over sine I, Navia beta. If the light is traveling, if the light is traveling from glass into air, okay? The light is traveling from glass, G, the light is traveling from glass into air, and now they are asking to solve refractive index is 1.56, angle R, you have to calculate, angle I, you have read, it is 35 degree. So we are not solving this question. The calculation is same as we have solved in the last question. So we are not solving this question. And now we have another question. And in this question, I am going to teach you one more new formula to calculate refractive index. To calculate refractive index. No, no, no. अभी total internal reflection कहाँ से आ गया? अच्छा जी, I am teaching you a new formula of refractive index. Sir, formula number one, sin I upon sin R. Okay. Formula number two, sin R over sin I. Okay. And now I am teaching you a new third formula. Formula number one, air to glass. Formula number two, glass to air. And now the third formula is it is again to calculate refractive index. Okay. The formula is speed of light in air divided by speed of light in glass or in liquid, etc. Okay. So this is formula number three. This is formula number three to calculate refractive index. And obviously, speed of light in air, it is always denoted by small c. In the physics, small c means speed of light in air. You know a very famous equation, E is equal to mc square. So this c always represents speed of light in air. Okay. So c is the speed of light in air divided by speed of light in glass is v. Speed of light in glass is v. So this is a new formula which I am going to solve the next question. The next question from May June 2017. This is the speed of light in air. This is the speed of light in a liquid, and you have to calculate refractive index. So I'm solving. So refractive index is denoted by small n. In numerator, I will write speed of light in air. In denominator, I will write speed of light in liquid. And if you simplify these numbers, then 3 divided by 2, it becomes 1.5. 3 divided by 2, it makes 1.5. And if you have calculated refractive index, then we have one more question. Angle of incidence is 40 degree and calculate angle of refraction. And the light is traveling from air into glass. A ray of light is incident on the surface of liquid. On the surface of liquid, in this question, consider this is a liquid. The light is coming from the air, and now it is entering into liquid. But Amna, can you tell me the formula? If the light is coming from air into water, then what is the formula, Amna? No, no, no. It is sine I upon sine R. Because the light is coming from air into water. So the formula is sine I divided by sine R. Sine I given, yes, 40 degree. This is 40 degree. Sine R you have to calculate, and the refractive index is 1.5. So again, the same kind calculation which we are not solving, which we are not solving. Okay. And now we have another question, question number 37, May June 2019. Beta Amna, can you read the angle of incidence? This is the boundary. This is the boundary. This is the normal. Amna, what is angle I? This is boundary. Amna, what is angle I? No, no, no. Angle, yes. Angle is measured with normal, beta. Angle is measured from normal, not from boundary, not from boundary. Okay. So this is incident ray. Okay. This ray is striking on the boundary, but the angle of incidence is with normal. And with normal, the angle is 40 degree. So angle of incidence is 40 degree. And the new thing in this question is the speed of light is v, and when the light enters or crossing the boundary, the speed is 1.3. What does it mean? Speed in this medium is v, and speed in this medium is 1.3 v. So you know, okay, this is initial medium, this is the final medium. Okay, you are given these two media, and you can see the speed increased or decreased. Rafik, can you tell me the speed after crossing the boundary is increased or decreased? हाँ बेटा. Yes, yes, both are correct, sir. The speed is increased. Okay, when the number is less than one, it means the speed decrease. If the number is greater than one, then speed is increased. Okay, so in this medium, speed increased, and if speed increased, so you can say, sir, initial medium is glass, although it is not glass, it means it is a denser medium. So initial medium is glass and the final medium is air. Why? Because the speed increased. After crossing the boundary, the speed is increased. Okay. And now they are asking calculate angle of refraction. Calculate angle of refraction. And tell me one thing, Rafe, can you tell me when the light crossing boundary, you can see the speed increased. Speed increased. If speed increased, then the light will bend towards the boundary or away from the boundary. Rafe, speed increased. The light entering into the air, consider. Then the light will bend towards the boundary or away from the boundary. Rafe, away. You are right. The light will bend away from the boundary. Okay. In this question, they are not asking, I am asking myself. Okay. So light will bend away from the boundary. Okay. And now, as the light traveling from glass into air, then Amna, can you tell me what will be the formula? Sine I upon R or sine R upon sine I? I am asking you, Amna. But Amna, yeah, sine? Repeat, repeat. Sine R divided by sine I. बेटा आमना इतनी सी बात को आप नहीं अभी तक कैच कर पा रही तो किस तरह से हम फिजिक्स को लेके चल सकेंगे बेटा। तो बिल्कुल एबीसीडी हम आपको देखे लेके चल रहे हैं इतनी देर से कि अगर लाइट एयर से गिलास में आ रही है फ्रॉम एयर टू गिलास then the equation is sine I upon sine R. If the light is traveling from glass into air, then formula is sine R upon sine I. आप इसी में बेटा कंफ्यूज हो रहे हो बार बार। इट इज वेरी सिंपल बेटा, इसको आप लिख लें। बेटा आप ना कहीं लिखें इसको, नोट डाउन दिस फॉर्मूला बिकॉज यू आर मेकिंग मिस्टेक अगेन एंड अगेन बेटा। हैव यू नोटेड? बेटा आप ना हैव यू नोटेड? ओके ओके ओके। बट इन द नेक्स्ट क्लास बेटा यू मस्ट मेमोराइज इट एज वेल एज यू मस्ट वॉच द वीडियो एज वेल। ओके, because if we move slow then obviously we cannot complete the course, ठीक है बेटा। So in this question you are not given refractive index as well. Okay, so this question is very difficult and how do we solve it? So I am solving it on your screen। राफे भाई, साइन आर अपॉन साइन आई तो डिसाइड हो गया है। ओके, साइन आर डिवाइडेड बाय साइन आई। ओके यार राफे, ऑन द लेफ्ट हैंड साइड रिफ्रैक्टिव इंडेक्स इज नॉट गिवन। रिफ्रैक्टिव इंडेक्स इज नॉट गिवन, ठीक है ना। वी आर गिवन स्पीड, speed of light in air divided by speed of light in other medium, then what should I write here? What should I write here? G. Rafe, it is a very difficult question, that's why I am asking you। Rafe, या अल्लाह, राफे भाई ने भी गलती कर दी यार। राफे, refractive index is always greater than 1। Refractive index is always greater than 1, so is greater speed always in numerator, okay, and slow speed always in denominator, okay, always high speed in numerator and slow speed in denominator, always greater angle in numerator, always smaller angle in denominator, okay beta। So it will be 1.3 v divided by v is equal to sine r upon sine I. And now I am putting the values. I am putting the values. V cancel out. Yes, V will cancel out. On the left hand side, it is only 1.3. On the right hand side, sine angle R. Sir, angle R we have to calculate. Angle R we have to calculate. Divided by sine angle I, and sine angle I is 40 degree. But Afaria, your microphone is working or not, beta? Okay, okay, okay. Okay, but now this sine 40 is shifted on the other side. Sine 40 is shifted on the other side. So it becomes 1.3 into sine 40 is equal to sine r. We have to calculate sine r, okay? So I'm writing 1.3 on the calculator, multiply sine 40. So this number becomes 0.83. 0.83. Sir, 0.83 is equal to sine angle r. And if you have to calculate angle r, then this sine will becomes sine inverse, and sine inverse 0.83 I'm writing on the screen. Shift sine 0.83, so the answer is 56 degree. So the answer is 56 degree. And now Faria microphone, if it is working, then it is the last question, beta. It is the last question. Faria? But a speed of light in air is given, refractive index of water is given, and you have to calculate speed of light in water. And it is March 2018 paper question. Can you tell me the formula? How do I calculate refractive? How do I use formula? You are given refractive index. जी बेटा what n is equal to Faria. Uh, yes, you are right. You are right. And in this question, we have to calculate the speed of light in water. So I am making this V as a subject, and it is equal to C. You know, C is 3 exponent 8. Refractive index is 1.33. Refractive index is 1.33. And now I am calculating 3 divided by 1.33. Do not use exponent 8, okay? Only you divide 3 divided by 1.3. So it makes 2.25 and exponent remain as it is. Exponent remain as it is. So this speed is completed. So the first topic of today's class is completed. The topic name is refraction of light. And in this topic, the topic is completed. In this topic, I taught you, sir, when light traveling in air enters into glass or water, then its speed change, its wavelength change, its direction change. But remember, frequency never change. Then you should memorize these formulas. If the light is traveling from air into glass, then formula is sin I upon sin R. If the light is traveling from glass into air, then the formula is sin R upon sin I. And we have solved too many questions on this topic, and it is a crash course, so obviously I should run fast. And then I introduced third formula as well, that is the speed of light in air divided by speed of light in glass or in water. And we have solved few questions on this formula as well. And now I am starting the new topic. Total internal reflection we will study tomorrow. But right now I am teaching you the next topic, that is prism. So what is prism? My prism is in a school lab. The prism is like this, in which there are two triangular surfaces, and if you join them, then this shape is called prism. This shape is known as prism. Okay, but when we perform experiment in lab, then we use only the triangular surface, and we put this triangular surface on the white page, and consider I have a torch, I have a laser light, and the laser light is incident on the prism, and again, sir, the light is in air, the light is entering into glass prism, then obviously the light cannot continue the original path. The light cannot continue the original path. Sir, the light will follow this path. It means light is not going straight, not going straight, but bending. Okay. And when the same light reaches at this boundary, then it will not follow the straight line. So it will bend further. So you can see this is the incident ray, this is the incident ray, this is the refracted ray, and this is the emergent ray. This is the emergent ray. Okay. So light, हाँ बोले राफे? No, no, it is bending away from the normal. If I draw a normal here, if I draw a normal here, if consider this is the normal, this is the normal, you can now see this is the original path, not following original path. It is bending away from the normal. Okay, so the same rules will be used as glass block. Okay, and number one, number two, bending of light is called refraction. And remember, refraction depends upon frequency of light. Note down this sentence. This is very important sentence for the next two questions. Refraction means bending of light. The light is not following a straight line. Light is bending towards the normal or away from the normal. And refraction depends upon frequency of light. And you should know, sir, there are seven colors in white light. There are seven colors in white light. In white light. And these seven colors are Roy, G, Biv. So these seven colors are Roy, G, Biv. And I think everyone knows, sir, Roy means, so this is red color, this is orange color, this is yellow color, this is green, this is blue, indigo, and then violet. There are seven colors in the white light. And out of these seven colors, remember, the least frequency of red color and the highest frequency of these color. You should memorize. Without memorizing, you cannot solve these questions, which I am going to explain. Least frequency, yeah, highest frequencies of violet, and then ultraviolet and X-ray and gamma rays as well. So highest frequency is for violet, red least frequency, so it will bend least. Okay, if you compare red with green, the green will bend more. If you compare red with blue, then blue will bend more. Okay, so I'm going to solve this question on this knowledge. Green, greater frequency, greater bending. Blue, greater frequency, greater bending. Red, least frequency, less bending. And now I'm going to use this knowledge. I'm going to use this knowledge in this question. So the question is, so this is green light. This is green light. Okay, you are given green light and you are given the path of the green light. Okay, and now the question is, you have to draw the path of blue light. You have to draw the path of blue light. Okay, so this is the path which you are given. Sir, this is green light and you have to draw blue light. So can you tell me blue light, Amna, can you tell me blue light will bend less or will bend more than green? Amna, you say it will bend more. And let me check. Roy, G, Bev, you are right. So the frequency of blue color is high. The frequency of blue color is high. If the blue color frequency is high, then it will bend more. And if it will bend more, then this is the path of green, but this is the path of blue. I'm using blue color. Okay. This is blue light, as well as when it will leave the prism, it will bend more. So I can say this is green light and this is blue light. Okay. So the incident light is green. The incident light is green if The blue light is incident on the same path. The incident at the same path. Incident at the same path. Blue and green, same path incident. But when light passes through prism, then blue light is bending more. Blue light is bending more. Faria, why blue light bending more? The higher frequency, more bending. Okay. But Faria, then there is a mathematical question. The mathematical question is you are given the wavelength of blue light. You are given the wavelength of blue light. And they are asking calculate the frequency of blue light. Do you know, Faria, any formula which relates frequency with wavelength? Faria, beta. But Faria, what is the formula which connects frequency with wavelength? The formula is V is equal to F lambda. अच्छा बेटा, both students Faria and Amna, just after my class, then you should send me how much course have you covered in your school. Because right now I am teaching you refraction, but you do not know the refractive index. You do not know this basic formula V equal to F lambda. So it should be cleared कि how much course have you covered in your school. Then I can plan कि how do we study. ठीक है बेटा? So just after my class, I hope कि you will share me how much chapters, how many topics you have covered so that I can plan your course. Okay. And now I'm solving this question. This is a very basic formula. V is equal to F lambda. In this question, frequency we have to calculate. Wavelength is 4.8 exponent minus 7. Abata Navia, can you tell me what is the speed of blue light? Navia, what is the speed of blue light? Navia. Rafe, do you know what is the speed of blue light? Oh, bhai, the speed of all lights, the speed of all electromagnetic waves. जी अब जब बता दिया तो फिर आप बता रहे ना. The speed of all colors, the speed of all electromagnetic waves is 3 exponent 8. 3 exponent 8. And now I am calculating frequency. And frequency is 3 exponent 8 divided by 4.8 exponent minus 7. And obviously, by using calculator, you can calculate frequency. You can calculate frequency. Okay, so I am stopping recording.